In this video, I want to introduce you to one of the methods of integration that you typically see in Calc 2, or when you do integral calculus. I'm not going to get very deep into it, but I want you to have seen some of it. When the argument is linear, i.e. m times x, where m is some constant, then it's very easy to do the integral if you already know how to integrate the function in the first place. You'll see what I mean in a second, but to state it, if the integral of little f of x dx is equal to big F of x plus c, then the integral of little f mx dx is equal to 1 over m f of mx plus c. So what do I mean by that? Let's say you've got sine of 3x. I know that the integral of sine is negative cosine, but I've got something on the inside that's not a plain old x. So I need to take that into consideration. So I will multiply out front by 1/3. And the negative is because the integral of sine is negative cosine. So I have negative 1/3 cosine of 3x plus c. We're doing this because if you think about it going backwards, using the chain rule, if I take the derivative of cosine of 3x, I will then have to multiply by 3. But over here, I don't have a 3 out front, so I need the 1/3 here so that they will cancel. Here I have the integral of secant of 4x, tan of 4x. Because the arguments are the same, both are 4x, 4x. And I know the integral of secant times tangent is secant, then this will be 1/4 secant of 4x plus c. Now, suppose I have something like this, integral of e to the x squared dx. Well, then I'm screwed. I can't do this. This is x squared, this is not linear. The only way to do this really, you'll find out in Calc 2, is you have to do some numerical methods, because we do not know how to integrate. Now, if I had the integral of x, e to the x squared dx, then I could do some substitution, and I would get 1/2 e to the x squared plus c, but that's for another day. That's not for us. Let's say I have the integral of 1 over 4x squared plus 1. Does this look familiar? I see the x squared plus 1 on the bottom, so I'm thinking arctan, but that 4 is annoying me. Is it annoying me? Maybe a little bit. Let's see if we can rewrite this. Remember that the integral of 1 over x squared plus 1 dx is arctan of x plus c. So if I can get something here like mx quantity squared plus 1, then I can use that baby sub I was talking about before. This can be rewritten as 1 over 2x quantity squared plus 1. Okay, so now I know what to do. I know what 1 over x squared plus 1 is, and the only difference here is I've got a 2 cozied in there with the x. I need to multiply by 1 over 2 out front, and then I'll have arctan of 2x. It's a little bit harder to see than the sines and the cosine ones. Let's try one that's really gross. Here I have x squared plus 9. Now for arctan, it has to be x squared plus 1, and this is a 9. So the first thing I'm going to do is get rid of that 9 by sucking it out to the front. So I have 1/9. It's out of my hair. It's in front of the integral. We'll deal with it later. I have 1 over x squared over 9 plus 1. I've got my thing squared plus 1. Let me write this so I can see it a little bit better. So I've got my thing squared. The coefficient here is 1/3 plus 1. So I'm going to have an arctan. And when I do the arctan, I'm going to have to divide by my coefficient. But my coefficient here is 1/3. So to divide by 1/3 means I multiply by 3. So I've got 1/9, because that's what I had out front. 3 times the arctan of x over 3 plus c. Let me clean that up a little bit and write 1/3 arctan of x over 3 plus c. What if I have more than just mx? Like mx plus b in there. Again, this is basically linear. When you do the chain rule and you multiply by the derivative of the inside, you're just multiplying by m. So you're going to have to put a 1 over m out front so that it cancels out. So for example, I've got the cosine of 4x plus 1, nice linear expression. I know the integral of cosine is sine. So this is going to be 1/4, because of that, sine of 4x plus 1 plus c. This one's a little bit harder to see maybe. If you remember that the integral of 1 over x dx is the natural log of x plus c, well then I've just got this line here that the coefficient in front of my x is a 4. So I'm going to have a natural log of this crap on the bottom and a 1/4 out front. So we'll do a lot of practicing for this, but if the function on the inside is not too complicated, you should try to do these in your head. Because once you get into Calc 2, they'll be a lot more complicated, and you don't want to waste time spending a page trying to do this sort of integral.